Today, Intel is launching their new generation of processors under the codename Arrow Lake, and we're having two processors right here. These are Intel Core Ultra processors. We're having 9285K and 5245K. So this will be, I'll try to wrap it up a bit so you don't have a half an hour video, but we're going to have loads of synthetic benchmarks and gaming benchmarks. But before we do continue on those, let's dive in a bit into specifications and go into some details that you need to know regarding these processors in general. Specifically, today I'm going to talk about the Ultra 9, and tomorrow there's going to be another video about Ultra 5, so you'll have separated benchmarks as well as the ones for the motherboard that I tested it on. So I'm going to use, and I did use, MSI MAG Z890 Tomahawk Wi-Fi, paired it up with Kingston Fury Renegade DDR5 RGB 2x16 gigs at 8000 megahertz, and for the drive I used Kingston Fury Renegade PCI 4.0 4 terabytes SSD. Now, the processor was cooled with Lian Li Galahad 2 LCD 360, and we're having quite nice airflow through the case, so you know how everything goes when we're talking about the cooling. In addition to everything, I paired up the Ultra 9 processor with the MSI RTX 4080 Super Gaming X Slim, so you basically know the whole combination that goes into this. But before we go into those benchmarks, let's check out some details that you need to know. And starting it off with what they stated is Arrow Lake processors are designed for enthusiasts. We're having apparently 30% lower power consumption and 2 times more graphic performance. There's also, as I stated for the motherboard review, there's loads of stuff still since Computex going around AI, and since we're having a huge AI hype, we're having a new AI experience ecosystem with 100 plus ISV partners, 300 plus AI features enabled, 500 and more AI models supported. For instance, object detection, time series image translation, natural language processing, text monodepth, and so on, right? So we're having 24 cores, 8 P cores and 16 E cores. That's 24 threads because we lost hyperthreading, or so to say. Now, one thing that I like to mention is that we have the same compatibility with LGA 1700 for the coolers. So if somebody is going and advancing to that, you don't have to worry about that. Intel Thermal Velocity Boost frequency is 5.7 GHz and Turbo Boost Max Technology 3.0 frequency is 5.6, P-Core Max Turbo frequency is 5.5, P-Core Base frequency is 3.7, E-Core Max Turbo frequency is 4.6, and E-Core Base frequency is 3.2. Now we're having 16 SkyMount E-cores and 8 Line Cove P-cores, 3 MB L2 cache, 36 MB shared L3 cache, and 18 execution ports. Then we have E-core architecture. We have 26 dispatch ports, 96 billion parallel fetching, 2 times L2 cache bandwidth, double L2 caching bandwidth, double AI throughput from 4 times 128-bit FP and SIMD vector, 4 MB shared L2 cache. The 3D packaging, so we have IHS, we have GPU tile, SoC tile, IO tile, filler tile, compute, base tile, and then we have the package. So it's actually 33% reduction in package size. Now, I'm telling you all of this information, what I got shared from Intel, just to give you more heads up what's the goals for this processor, for this series, what's the future and what they can expect, and of course some specs. 8000 MHz XMP enabled should be the sweet spot for memory frequency. Now 8500 MHz around and above are likely to require a switch to Gear 4, which is 4:1 ratio. So basically, to sum it up quickly a bit and not to discuss too much about these details, we're having 24 cores, 18 P cores and 16 E cores, 24 threads, 4 GPU cores, 13 TOPS MPU, 5.7 GHz maximum. We are having 48 PCI lanes, 20 PCI 5.0, 24 PCI 4.0, 4 ESPI, 10 3.2, 14 USB 2.0, 8 SATA 3.0. And the MSRP for the Ultra 9 285K is $589. loads of information when we're talking about details and specs, but we need to go to benchmarks to see the performance, because I know you guys are mostly interested in that. And we're going to go with some synthetic benchmarks in workflow and rendering and cryptography, and eventually go into gaming as well. But of course, I'm going to start with regular stuff like AIDA 64 Extreme Edition and the Cinebench R23. So system stability test, CPU went up to 74 degrees, clock speed at 5500 megahertz, GPU at 63, irrelevant, but the power consumption was 206.4 watts, which was quite solid, I do have to say. Then we go with Cinebench R23. Multi-thread score was circling around, started at 39,646, and it did circulate around 39,600, 700, something like that, with thermals going from 76 to 77, with clock speeds constantly at 5400 megahertz. Now the consumption was 240 watts. When we compare it to 4900K, multi-score was 40,569. In this scenario, it kind of goes lower than the past gen, but then we go with multi 10-minute test throttling, 239.7 watts, 80 degrees Celsius, 30 passes, and the score was 38,756. Single thread score, 2,288 points, multiplier ratio was 16.94, and when you compare it to 4900K, single thread score was 2335. Then we go with cache and memory benchmark. So as I stated, Kingston Fury Renegade DDR5 RGB 2x16 gigs 8000 megahertz at CL38. In this benchmark, the CPU went up to 65 degrees, 188.9 watts. Read speeds 114.5 gigabytes per second, write speeds 97,288 megabytes per second, copy 102.04 gigabytes per second, and latency was 89.3 nanoseconds. This looks quite alright, and really don't have to add anything to this part. Then testing out PCI Gen 4 and Gen 5 SSDs. I use Kingston Fury Renegade PCI 4.04 terabytes, and for Gen 5 I use Team Group T-Force Z540 Gen 5 x 4 1 terabyte. The Gen 4 didn't work as I expected, because the ASSD read speeds go up to 64,038 megabytes, while the write goes 6,326 megabytes per second. Auto disk benchmark goes a bit higher with 6.61 gigabytes per second, while the write speeds go up to 6.42, and Crystal Disk Mark 6622 read speeds, while the write speed 6531. Usually this SSD should go up to 7300 megabytes per second, while the write speeds around 6800. So here it must be something with the motherboard in terms of BIOS update or something similar to that. But then we go with Gen 5 SSD, and this one in ASSD went up to read speeds 8550, while the write speeds 8429. Which I thought this is a joke. And then we went to Autodisk benchmark with read speeds 10.88 gigabytes per second, with the write speeds 8.96 gigabytes per second. And finally going in Crystal Disk Mark with read speeds 11,630.97 megabytes per second, while the write speeds 9,485.43. I think this is quite alright, and I don't have to say anything else. The Gen 5 works properly and there's no issues with that. Then we go with Corona 1.3, where it actually does perform quite outstandingly good in this scenario. So 209.6 watts, 77 degrees Celsius, 45 seconds to finish the render, compared to the AMD Ryzen 9 7900X3D with 51 seconds, and it did 10,707,900 rays per second. So that's 6 seconds advantage compared to the 7900X3D for the render time. Then we go with Indigo benchmark. In this scenario, we had 62 degrees Celsius, 155.3 watts consumption, bedroom 3.341 million samples per second, where we compare with 7900X3D, which had 3.543, and 7900X 3.791. Then Supercar, 8.589 million samples per second. 7900X3D had 7.918, while the 7900X 8.650. So it varies in this scenario. Corona 10 CPU frequency went up to 4.8 gigahertz, while the score raised per second was 12,458,878. Quite solid, and there's nothing actually to add here. I also went with Blender with render time, 5400 megahertz clock speed, 74 degrees, and 245.8 watts of consumption, 56.84 seconds to finish up the render. 4900K actually had 61.3, 3900K 65.4, 14700K 67.9, and 7900X 80.1. 12900K 86.8, and you can see the rest. I mean, it really did outstanding here in Blender. Geekbench 6, 211.4 watts of consumption, single thread 3255, and then we compare with 4900K, which was 3079, 3900K 3007, and the 7900X 2961, while the X3D 2835. Multi-thread score 23,425. With comparison to 4900K, that went up to 20,698. I don't even have to mention the rest because you can see them in the charts. So it kind of is self-explanatory in that scenario. Now Jetstream 2. Here we have something interesting, a bit reversed scenario where 4900K scored 306,876, while the Ultra 9 285K went to 302,959. Right beneath it is 3900K with 302,176, and 10,000 lower is 14700K. 7900X is actually 20,000 points below, so yeah. Now we go with AIDA 64 AES encryption cryptography benchmark. Ultra 9 285K. The speed was 252.2 gigabytes per second, while the 14900K 165.5, 3900K 163.6, 7900X 149.1. And then of course I went with 3D Mark, so it's going to be a bit different because we have three scores: 7900X 3D, 7900X, which use the same GPUs, 7900 GRE. In my scenario, the only difference is that I'm using RTX 4080 Super. So Firestrike score is actually almost very similar, and I'm going to skip GPU score. But when we go with combined score, we have a bit lower score in this Firestrike. Then we go with Firestrike Extreme score, which actually advances for 3000. And going with physics score, it advances by 8000 depending on the processor. Combined score for the Extreme is somewhere, well, basically lower than both. But then we go with Ultra score, we're having 3000 or 4000 more, and the combined score is actually in this scenario for Firestrike Ultra by 2000 or even 2,500 points better. Continuing to TimeSpy score, we're having 24,840 compared to 19,000 and 17,000. Then we go with CPU score, 19,887 compared to 14,533 for the 7900X, and 7900X 3D 13,834. TimeSpy Extreme score goes above 4,500 better. And then we go with CPU score. So 7900X 9609, 7900X 3D 8834, while the Ultra 9 285K had 13,214. I also did easy bench with Unreal Engine 5.1.1 with GPU particle, and basically I'm not going to go too much into details here because this is the first processor that ran these benchmarks, so I don't have any literal comparison, but this might help you with these 6 benchmarks. So we have GPU particle and photogrammetry. When you take into consideration the total frame rates, average frame rates, and all the FPS that I have right here, might give you some idea compared to your current processor or anything if you have some information somewhere else, just to give you an idea how it performs in this total segment. have 3D Mark CPU profile benchmark. So I compared Ultra 9 285K with 7900X. Maximum thread, so 24, 17,390 compared to 7900X, which had 12,958. The rest you can see, but it's totally a bit irrelevant. Even the single core goes by 200 points better than this. PC Mark 10, overall score 8892, essentials 11,563, productivity 12,006, and digital content creation 13,651. Now I think it's time to go with gaming, because I think I was going a bit too much with everything. So in comparison with 7900X3D, since I mostly use that processor for other benchmarks and I did test it out with RTX 4080, so we're going to have quite similar configuration when we're talking about general build. So Assassin's Creed Valhalla, average FPS in 4K for the Intel Core Ultra 9 285K, we had 107. The 7900X3D had 91, with the minimum FPS 59 compared to 47, and maximum FPS 211 to 189. The average temperature in Assassin's Creed Valhalla was 50. When you take into consideration all thermals, Assassin's Creed Valhalla, F1 2023, Deus Ex, Hogwarts Legacy, Spider-Man Miles Morales, Witcher 3, PUBG, and Starfield, the average thermals on the processor was 53, which is really great. Now let's continue with F1 2023. Average FPS was 139, while on the 7900X3D was 147. Deus Ex average FPS 38.4, or for the 7900X 3D 37. Hogwarts Legacy average FPS 63, 77 for the 7900X 3D. Miles Morales 64 and 66 for 7900X 3D. Witcher 3 49, while 59 for 7900X 3D. PUBG average FPS was 96, while 113 for 7900X 3D. And then we have Starfield, which I got 63 average FPS. Unfortunately, I didn't test out Starfield on 7900X 3D at that point, so I don't have any data on that. But the average FPS was 63, minimum FPS was 33, and maximum FPS was 109. So to conclude it a bit, I really didn't want to go with 25 different games. I didn't want to go with too much synthetic benchmarks, not to bore you to death with those, but there is a conclusion behind everything. So when we compare Intel Core Ultra 9 285K compared to 4900K and 7900X3D, what we get in synthetic benchmarks, quite nice advantage when we're talking about Intel Core Ultra 9 285K. It's not in every single synthetic benchmark, but in majority there is an advantage when we're talking about performance, and not only performance but also consumption, not compared to 7900X3D, but comparing to 4900K, and much lower thermals in both scenarios, because you know the thermals of 7900X3D and what I usually test out, which usually go from 80 to 90 degrees, and this didn't pass in only one benchmark. It went up to 80 degrees. So in that consideration, you have to take that as well. But usually in gaming, it was around 55, 53 on average. Let's put it this way. But all in all, 74 was, I would say 75 was an average in synthetic benchmarking when we're talking about thermals. So I would say this actually does do quite nice job when we're talking about synthetic benchmark workflow and all the other tests that I did. But when we go into gaming, now of course I didn't do much gaming benchmark, but you can already see the pattern in a couple of these games. So what happens here is that 285K isn't much advanced compared to 4900K, compared to 7900X3D when we're talking about Intel AMD, but it kind of lowers the thermals, which the thermals are insane, and this is only with Galahad 2 360. Imagine if you go with a custom loop, because I know people were going with custom loops in 4900K because of the thermals and everything all together, but lowering down the thermals, the consumption was quite nice and always stable. It didn't go above, I think I never went above 240 watts, so even in peaks. So this is quite good, and in those terms, okay. But in gaming, it doesn't go way above past gen. It doesn't go above past gen actually, and it doesn't go above in some scenario it does compared to 7900 X3D, but we're having some, let's say, lower FPS, lower advantages with this processor compared to past gen and compared to some AMDs. Unfortunately, I never had a 7800 X3D to give you some comparison, since I know this CPU is quite lately popular, but in this scenario, I hope the 7900 X3D will suffice, and 7900X as well, which I had prior to this processor. Now, one more thing, and to sum it all up, I can say that this is a good step forward compared to 13 and 14 gen. It's not overheating, it doesn't create that kind of problems. It has much lower consumption. So workflow, synthetic, and all the other stuff that we're going with standard benchmarks, the Intel Core Ultra 9 285K goes quite well, and I'm really satisfied with that. In gaming, it's not that much. It's not that much. It really varies, but if you're aiming for something that has lower consumption, lower thermals, so you don't have to worry about it, you can sacrifice a bit of gaming for your workflow and stuff like that, this might be a good processor. And we're going with something completely different here, with much better performance per watt, and that is, well, basically consumption, and that is quite solid. I think this is a great step forward compared to past gen, which I already mentioned, so I'm gonna leave it up to that. Now, the link in the description is based on Intel Core Ultra 9 285K, and for tomorrow I'll place the Intel Core Ultra 5 to pair it up with MSI MIG Z890 Tomahawk Wi-Fi, and or even higher. It really doesn't matter, because that motherboard really worked quite solid with this processor, so you'll be quite satisfied with that pairing. If you have some questions or comments, don't forget to leave them in the comment part below, and if you like the video, don't forget to subscribe, hit the like button, and click the notification bell for future content. See you soon, guys. Bye bye.